Hi, this is Mrs. Marina. Welcome to section 7.3, Multiplying Polynomials. This one is on special cases. Let's turn your student companion book to page 146 and look at example 1. Example 1 is asking us to determine the square of a binomial. So we're going to find each product. We're going to do this with a binomial and then also see how this could apply to integers as well. First, let's note a common error. This binomial, the 3x minus 4, that quantity squared, does not equal the 3x squared minus the 4 squared. No. We need to expand this using what we learned in the previous section, either using FOIL or the area method. Let's try with the area method. If we set up our box, this 3x minus 4 quantity squared, what this does mean is 3x minus 4 times 3x minus 4. That's what we need to set up. So we have 3x and minus 4, and then down the side, 3x and minus 4. So we can multiply 3x times 3x. We get 9x squared. 3x times negative 4, we get negative 12x. And then 3x times negative 4 again, we get negative 12x. And negative 4 times negative 4, we get positive 16. And then if you'd preferred, you could have used your FOIL method. We'd end up with the same 4 terms. And now we'll combine our like terms, so the negative 12x and negative 12x. And so what we get for our final product is the 9x squared minus 24x plus 16. Let's generalize this result. In our example, we can see that our 3x times 3x, that was our 9x squared. So 3x squared gave us the 9x squared. And then negative 4 times negative 4 squared gave us the 16. But what about this middle term? This middle term, we have twice the product of the negative 4 and the 3x. That happened twice. So this term is that negative 4 times 3x, but we double this. That's where we get this 2ab. And we can see that this also applies to a binomial squared when we're looking at a difference, so a subtraction. So both examples, we end up getting our a squared and our b squared with that middle term, the 2 times a times b. If we're looking at a sum, then we get the plus, or a difference, we get the minus. We could use this shortcut for integers as well. If we think about our 71 squared, I don't have that one memorized, but we could separate this to a 70 plus 1 squared, and then use the same pattern. We get our 70 squared, and then at the end, plus 1 squared, and then in the middle, plus 2 times 70 times 1. 7 times 7 is 49, and then double zeros, plus 2 times 70 times 1, so 2 times 7, 14, with 1 0, plus 1. And so if we add these up, we get 5041, so 5,041. Let's add one more part C, just for extra practice. Let's find the product of 2x plus 5, the whole quantity squared. If we use our shortcut pattern, we'll take the first term and square it. At the end, we'll have our last term and square it. And then in the middle, we have 2 times each term. So our 2x squared gives us 4x squared. 2 times 2 is 4, and then x times x squared, plus 2 times 2 is 4, times 5 is 20, but don't forget the x, and then 5 squared is 25. So when we were learning this, it looked like there was a lot more going on over here, but in summary, that's how we can use the pattern as a shortcut. At the end of the day, if you prefer just using FOIL or the area method, you're going to get the same answer. But this might be a shortcut for you to complete problems a little quicker in the future. Example 2. Find the product of a sum and a difference. Whatever you thought of that first shortcut, this one's my favorite. So I hope you'll give this one a try. The sum and difference really does save you a lot of time when you recognize it. Let's first look at this problem by doing it the long way. We've got our 2x minus 4, and 2x plus 4. What we need to recognize is that this is a sum and difference of the same term. So we have 2x minus 4 and 2x plus 4. The only thing that's different is the sign. That's the pattern we want to recognize. When we work this out, 2x times 2x, we get 4x squared. 2x times negative 4, we get negative 8x. 2x times positive 4, we get positive 8x. And then 4 times negative 4, we get negative 16. What we see in this example is that our diagonal terms, the negative 8x and positive 8x, they're going to cancel out. But if we want to write this out, we get 4x squared minus 8x plus 8x minus 16. My negative 8x and positive 8x, when we simplify, will cancel, and we just get 4x squared minus 16. And so when we're asked to find the product of a sum and difference, the product will always be the first term squared minus the second term squared. Let's apply this to integers as well. This one might be kind of tricky with integers, but it's fun to look at. If we look at the 56 times the 44, this could be written as 50 plus 6 and 50 minus 6. This part B is just for fun. We really don't see problems like this often. But the pattern will still hold true. When we work this out, we get our 50 squared minus 6 squared. 50 times 50 is 2,500 minus 36. And we end up with 2,464. That would be the same if we just multiplied 56 times 44. That one's kind of fun. This is the one I want you to recognize though. So when we do have a problem where it's a difference and a sum and the numbers are the same, we can think of the first term as your A and the second term as your B, and just jump straight into this. This is your 2x squared minus the 4 squared. All right, I told you I like these ones. Let's do two more real quick. For part C, let's look at the quantity 5x plus 6 times the quantity 5x minus 6. When we work this out, using our shortcut, we'll look at our 5x squared minus the 6 squared. 5x is my A and 6 was my B. 5x squared is 25x squared, and then 6 squared is 36. That's it. That's my final answer. And you don't even have to do that middle step. If we look at part D, 3x minus 1 times 3x plus 1, 3x times 3x, we get 9x squared. Negative 1 times positive 1, minus 1. And we know, just like our example in part A, those diagonal terms will always cancel out. So we don't end up with a middle term, we just get the first term squared minus the last term squared. And that's it for section 7.3. Make sure you copy down all your notes and bring your questions to class.